And now let's see how we can run this chi-square analysis in SPSS. The first one that we're going to do is the chi-square goodness of fit. And we're going to do it in two different ways. One is when we assume we have equal distribution across categories, and in another case when we actually have unequal distribution, we have some theoretical distribution or hypothetical distribution that we want to check against. All right, so first we're going to do the chi-square goodness of fit. To do that, we can go under Analyze and go down to the non-parametric tests. We did mention that chi-square is a type of a non-parametric analysis. And we're going to go down to Legacy Dialog and we're going to select chi-square. Let's work with ethnicity. So across ethnicity, we have 5 different groups. I'm going to go ahead and select that. And what I'm going to leave is I'm going to leave as all categories being equal, right? So we have 5 categories. Currently we have 100 folks in our data set, so we really are expecting to see 20 folks in each category. And that's all we have to do. We're going to go ahead and hit OK. And here it is. You can see here are our observed values across the 5 categories. Here's our expected values, as I said, because we have 100 people and we expect all the categories to be equal to each other. Our expected values are 20 for each category. And you can see the difference between observed and expected. And here's our chi-square test. We can see the value of the chi-square, degrees of freedom, whether our p-value is less or greater than 0.05. In this case, our p-value is less than 0.05. So that means that our test is significant. If we think about what our hypotheses are usually with chi-square goodness of fit, we have that the null hypothesis is that our observed values equal our expected values, or the alternative is that our observed values are significantly different than our expected values. And this is what we have here. Since our p-value is less than 0.05, that means that our test is significant. Our observed values are significantly different than our expected values. If we expect to have the same distribution across all of the categories, we can also state that as what we would expect to observe purely by chance. So we can also say that the observed frequencies are significantly different from what we would expect to observe by chance. And here's the little note at the bottom, and this is one of the assumptions that go with chi-square test, is that we do not have any cells that have expected frequencies of less than 5. So this is how we're going to do the chi-square when we actually have equal distribution across categories. We have expectation that we're going to have exactly the same number of people or observations across categories. Let's see what is going to be the case if we have different distribution. Let's say that we would expect our first 2 categories to have, let's say, 30%, and the last, let's make this a little bit easier. Let's say that we're gonna expect our first 2 categories to have together to have 70%, so that is 35% each, and then the rest of the categories to have 10% each. So altogether we're going to have 100%. So let's see that, or let's say that that's going to be our distribution of whatever those first categories are. We don't know, but we're going to try it out this way. So we're going to go under Analyze, and go again to non-parametric tests. legacy dialogues, and we're going to select our chi-square. We still have our ethnicity selected, but now what we're going to do is we actually are going to set our values, and those are going to come in the same order as our categories. So here we said that the first two categories are going to be 35% each. We have 100 folks, so really our expected values are to be 35 for the first category, and then 35 for the second. Then the third one, the third, the fourth, and the fifth are 10 each, right? Okay, so here's 1, 2. These are the expected values for the first two categories, and then 3, 4, and 5. The order in which we put it does matter, especially when we have different distributions, so make sure that the order that you put in the expected values match the order or the way the values are coded in SPSS. And we're going to click OK. And as you can see here, we have a very similar table. We have the first categories, what our observed values are, what we expected to have, and this is based on the values that we put in SPSS. And then 3, 4, and 5, we said the expected value is 10, so we have those ready. Here we have a different chi-square test, or chi-square value rather. We have degrees of freedom, whether the test is significant, yes or no, and the number of cells that we have with less than 5 as expected value. In this case, we do not have any cells, so we do not have a violation here. But you can see it's the same interpretation. We just have to be careful about what is the context of our problem or scenario, whether we need to use equal distribution across categories, or if we have some kind of outer distribution beyond equal, and how we're going to put the values in SPSS. And now let's see how we can run the chi-square test of independence in SPSS as well. Here we have two variables. We have a counseling variable that has 1s and 0s. 1 stands for somebody who received counseling, and 2 stands for somebody who did not receive counseling. And then our second variable is behavior. Again, we have 1s for those who exhibit aggressive behavior, and 2 for those who did not show any aggressiveness. This example is very similar to the example we worked by hand when we worked with the vitamin C and getting the flu example. We have 2x2 table in terms of we have a two categorical variables each with 2 levels each. So here we have counseling, yes or no, and behavior, yes or no. In chi-square, you can have variables, categorical variables, or factors that have more than 2 levels. That's perfectly fine. I'm using the 2x2 example so that we can actually practice calculating the odds ratio. So let's see how to run the chi-square test of independence. We're going to go under Analyze, Descriptive Statistics, and we're going to select Crosstab. And in this case, it doesn't really matter which variable goes where. We need one variable that goes on in the rows area and one variable that goes on the rows column. Under Statistics, we're going to want to make sure that we select our chi-square as our test. Okay, and let's go ahead and click OK. And here is our table. Again, if you think about, if we think of counseling as the exposure, but if somebody received the counseling or did not, and what is our outcome, whether somebody has aggressive behavior or does not, Here is the same or very similar 2x2 table, just like the one we worked with when we worked with vitamin C and getting the flu. Here is the actual test, the Pearson chi-square. This is the value of the chi-square, degrees of freedom, and the p-value. So this is going to tell us whether our chi-square test is significant. In this case, 0.423 is greater than 0.05, which means that our test is not significant. If we think about what our hypothesis is, the null hypothesis, the two variables are independent of each other. Our alternative hypothesis is that the two variables are dependent of each other. In this case, we have a non-significant result, which means that the two variables are not dependent, or the two variables are independent of each other. In this case, since we have non-significant results, we stop here. There is no need to calculate an effect size. If, however, we had significant results, we can calculate odds ratio. In this case, SPSS is not going to give you automatically the odds ratio, but you can use the data from here to calculate the odds ratio by hand.